Good afternoon, everybody. I'd first like to thank the organizers for this opportunity to come back and to present to you. It was this time last year that we had just launched our service, literally just a week before this session. And a lot of what I'm going to be talking about today is what have we done and what have we learned. The title, kind of what talks about the focus, is what is the role of the cloud in the future of robotics? And in particular, the title, the Robotic Edge. There was a definition earlier today of a robot being a computer, which I agree with, but I also think of it as an edge computer, something which is often far away, sometimes disconnected. And the edge is getting to be a really interesting place. Edge computing devices are getting more and more powerful. Autonomous cars have 4, 6 GPUs on them. They have a network. Increasingly, we want to process data closer at the edge. The edge will disrupt the cloud, but the cloud is not standing still. We're seeing connectivity moving at a faster pace than I've ever seen before in terms of coverage, in terms of ubiquitous coverage, but computing is also moving closer to the edge. There's a comment earlier today about having disconnected operations in warehouses. I can guarantee you that will not be a case in the years to come, but it still begs the question, what is the role of the cloud? When is it appropriate to partition functionality between cloud services, where we can distribute information, distribute compute, take on big data tasks, and what makes sense to actually put on the robot? And there's also cost implications as well, which my friends in the robotics teams are constantly struggling with. So I think there's a lot of open questions here, and this is going to be in play, an active area for the next several years. To put a finer point on my agenda, I will talk about the role of the cloud in the future of robotics. I'll do so through examples of customers that we have worked with. And these examples don't just pertain to AWS or Robo Maker. It's anybody who's thinking about building cloud services. I look forward to the day where we're talking here in ROS-Industrial about what cloud services to invest in for the community, and we'd be happy to actually actively participate in the development of those. But again, these are very general, and I will be throwing around the names of AWS services throughout. I'll try to translate them into English, but there's a reason I'm telling you that, and that will come at the end. I'll try to make sure what I'm sharing is clear. I'll talk to you about ROS-II. A little bit on our contributions to it. Not to be patting ourselves on the back, but you've heard a number of other people talking about the contributions that you're making. And even this morning, I was having conversations with people, and they're asking, where is ROS-II? What's the status? And I hope a takeaway you get from this is how many people are pulling ROS-II forward and behind it and supporting it and investing in it. Because a lot of the roboticists I talk to are concerned about when to make that move and what the maturity is. So I think we should all be talking about what we're doing. I'll close with another topic that's close to my heart, and some calls to action for consideration. Now, I can't assume everybody knows what the service we launched is, AWS Robo Maker. We had spent 6, 8, 10 months prior to the launch last year talking to teams that build robots and the applications that run on those robots, including teams inside of Amazon Robotics. And they spent far, far, far too much time doing stuff that frankly added no value to their unique intellectual property. Such as how do you get started building, developing, coding a robot? How do you actually test and verify your robot before you put the thing out in production? And how few people are able to do it right because of lack of resources? And then finally, once the thing is out in the wild, how do you actually deploy it, update it, and manage your fleets of robots? And so this is kind of an arc I'm going to take through this session today. Needless to say, we made a bet. We work customer backwards as we do at Amazon. We talked to people about what they used. And many, many companies, there was actually a nice call out earlier today in the talk from Open Robotics about how many companies built on ROS. ROS is a big focus, and Gazebo for simulation. These are things we're investing in heavily, and I'll talk more about that later. But we did something a little bit more. We don't want users to have to go read manuals for how to use AWS Cloud Services. But we thought these would all be useful. I'll tell you some that weren't. We thought we'd like to give developers connection to the AWS cloud. And we actually packaged that integration up as open source ROS nodes. So you don't have to know anything about how these services work. You see a ROS node, you see a topic. We maintain and create a secure connection to the cloud. We encrypt it, we keep it secure, and it's just a topic and a node, and things just happen. We actually went to CES, which is a Consumer Electronics Symposium, talked to about 100 companies the year before we launched, and everybody seemed to be excited about the ability to talk to the robots. If you don't know what Lex is in Polly, but you may have heard of Alexa, well, those are the two services that make up Alexa. Polly goes from text to speech. Lex, I can actually talk to it, and it will translate it to speech and send it to the cloud. And somebody in the cloud can actually write a whole dialogue script, not unlike the behavioral trees you saw today, to get more information until it finally can actually respond to it in an intelligent way. We thought that one would actually fly off the shelf. We've seen usage of it, but not as much as we expected. But I think we all know how tough consumer robots are, and that may have a lot to do with it. But everybody loves to get their log records, ROS-Bag and others, and metrics off of a robot. And CloudWatch gives you a way to stream log records, metrics up to the cloud so you can monitor your robot without using storage that's on your robot. S3, you'll see we're actually writing a ROS-Bag extension to actually upload in chunks, really big ROS-Bags. So again, giving you infinite storage in the cloud. People have loved that. Kinesis, this one's actually been a huge hit. For those of you who don't know, if you're ever going to an Amazon Go store, which I hope some of you heard by reputation, but you literally walk in the store, you pick up the items off the shelf that you want, and you just walk out. And there's cameras in the room, hundreds of them, streaming video and video-like data with machine learning algorithms that are actually tracking you and seeing what you purchase. And literally, by the time you walk out, your bill is on your phone. This thing streams video from hundreds of millions of cameras a day. And you can feed that video into machine learning models on SageMaker, which is pretty much what the Amazon Go store is doing. Amazon Recognition Video is a deep learning model that's been trained to recognize several thousand objects in a video feed. So if you want to know what your robot is seeing, literally you can put a $25 camera on it. We give you open source software to actually install our agent on the camera, stream it to the video, and you can start to get the tokens of what your robot is seeing out in the field. Or use SageMaker to build your own machine learning model. Have a security company that basically has trained the SageMaker machine learning model to actually recognize all of their employees. If it sees somebody at night it doesn't recognize, it sends an alert through CloudWatch. It records the video. Someone can get alerted and actually stream the video to their iPhone. Nobody had to write a line of code to get the robot to do this. So this is what excites us about what the cloud could potentially do. And you can do your own video processing. And there's actually a marketplace of third-party video processors. You may see demos of identifying age, sex, interest. All these are going to start to appear in a marketplace for video. So again, it gives a robotics developer a lot more power. This has kind of excited us. We've actually learned an incredible amount from Woodside Energy over in Australia. And this is what I mean by robots are just data-generating edge devices. Woodside Energy facility, mining over in Australia or outside of Perth. They've been doing nothing more than strapping a series of complex sensors out on their robots. They can send them out into their facilities, places where necessarily humans can't go. And they're actually streaming the data coming off these, and they're building a digital twin of their entire facility. An operator can go and actually look at a picture of their entire field, be able to click an individual sensor, see what the temperature was on the last reading. They've put cameras on it, feeding machine learning models in the cloud to realize when an oil reservoir is running low to get an alert. These robots are nothing more than just sensor-carrying devices connected where compute's taking place elsewhere. This particular environment's extremely hot. A lot of vibrations. Humans really shouldn't go in there, but they can send this in there. They talked about the first prototypes melting when they were first doing 3D printing, but now they use these to regularly monitor their facilities. But again, the ability to put a small payload of hardware, not necessarily a lot of compute, get that data off, computed elsewhere. This has actually been quite an interesting use case and opportunity to work with them. I'll move on past this. But this hopefully will give you a sense. Yeah, they're actually looking at FinFan. This is extremely hot where they're moving temperature well over 120 degrees Fahrenheit out of the building and trying to keep it cool. And they're looking for even hotter spots where they actually need to calm things down. So we'll see how the cloud extensions go. We're getting regular business and regular usage of it. But something that has really popped and it surprised us a little bit is we knew developers would actually use simulation as a service to actually, like when hosting Gazebo, to test their code. But some of the use cases that have come up that we've actually engineered for since have really surprised us. What we offer as a service, we have a number of pre-built 3D worlds. We're going to be adding more as well as a service to create some out of the box. We automatically scale for our customers, so you can start one simulation or 100, and we only bill based on how complex the simulation was. And again, we thought this would just be for unit testing, and that's what we designed it for. You could run multiple simulations in parallel, and I'll hit on that as we go. And you can take your very same application, pair it up against different worlds with slightly different variations in parallel, launch all these simulation jobs, and our service will actually do the scale out for you. We have hundreds of machines, thousands actually in a reserve pool, and we keep metrics on how they all did. And so a developer can come in and look at a single report on how all of their simulations did, and did any of them fail, and if so, what test did they fail? And then they can go actually look at the log records for that sim and see what the heck happened. Well, we were approached by a company that knows a little bit about robotics called iRobot, and they said, look, we're not always testing to the extent that we should. Sometimes we will push updates out into houses in production, and the robot will degrade in its performance, and we really want to get ahead of that. And with their current setup, it was very costly for them to actually do the testing. They had actually limited test cases, and they had a handful of people that could run the simulation. So in a nutshell, what we did, and I'll show you a little bit more detail, we built a CICD pipeline. Simply put, developers cannot check in code or changes that they're making off of some branch unless it passes all the simulations and the tests that they deem at the quality bar. And before they actually push a robot out into the customer's home, they run several hundred of these tests. And it actually runs in 1 hour versus the 3 weeks they were having to use for testing. And in fact, that's for the big test. For a simple check-in, it can be done in a few minutes. So it doesn't really get in the developer's way, and we've worked hard to get it that way. So a developer does check-in, literally go off and get a cup of coffee and come back, and they know whether their code has been able to check in. And of course, they've got lots of houses and lots of configurations and lots of complexity, so we're running all these in parallel with a set of tests against each one. And every time they realize they didn't have a good test and they had an issue in production, they just go back and add another test, and they maintain these going forward. And this was from Chris Kruger, the director of development there, said it's working. They're running basically 5,000 simulated missions a month. They've caught and gated and blocked things from going out into production or from check-ins happening. They're catching issues, higher quality mainline. I'm using Docker for local runs if a dev wants to do something on their laptop, and they actually were having a long conversation about how this number is going to go up much, much more as they start to make simulation part of their, and we heard that about the nav system too, but we see this as a pattern that companies are going to want to implement. So again, we're surprised. We're actually adding features to make this easier, but to do a little bit of an eye chart, all I wanted to show you here is a developer can use any development environment they want. They can actually fork. They can basically use simulation and ROS to write their code and build their app for their customer experience that they want to offer. When they make a request to actually check the code back in, we have a service called Code Pipeline. It can be thought of as any CI/CD system, but we'll actually take the code that the developer wants to check in. We have a ROS Docker container with all the right stuff you need to have in your Docker container for your ROS app. We build and bundle Colcon and put that in S3 as a staging area. And then basically we've got this function, this thing called Lambda. All Lambda is, it's a serverless. You can give it a function, namely start my simulation, and it waits till something plops down into the S3 bucket, it triggers it, and it starts all the simulations that define their test suite. These tests will run in parallel, and we're actually, as these simulations run, the checks or the tests that they want are Lambda functions too, which are monitoring a simulation. If it sees something that went wrong, we lost power, we went down the stairs, we got stuck, it adds a tag to it saying robot got stuck, robot ran out of power. These tags are checked when all the simulations are done, and if none of them were violated, it actually goes ahead and automatically advances the code, the check-in, to yet another code pipeline, which is actually going to try to check it in. iRobots decided that, hey, they actually want to run it on physical tests before they actually send it. They got a back of office, back of house area where they physically watch their robots do their little dance. And it's a quick sanity check. And then finally, when they're ready, they do over-the-air deployment to the robots which are in your home today. So this is how they're operating today. We're going to try to make this much simpler so people don't have to do all the setup we've done here. Like I said, there's a reason for some of these details for later. Another one that came up is basically how can someone simulate today having multiple robots. And we had a customer, and in fact, so they want to run multiple simulations and look at the interactions between them and test their logic. I have a company called Bastian. Bastian is actually purchased by Toyota. And Bastian makes robots that operate in warehouse. And so while they could get up to 8 or 10 in Gazebo before things started to melt down, they wanted to get up into the 20s or 30s. And so we worked with them to actually use our service to scale up to this level. And by the way, they had 5 people working on this, which they now have 0 people having to run this simulation fee. This is a nice trade-off that people can make when it's as a service. I'll show you what they built. So what we have here is, and this is an interesting way to change, I'm sure this has been done before. What we're doing here, guys, is that basically we have a Lambda function, and it's a parameterized every time I want to run a robot in a sim. All these gazebo worlds are exactly the same, so all the assets in the simulated world's all the same. This Lambda function is firing off a simulated job for every robot that we're going to attempt to simulate, all 35, 40. We've gone up to 50 concurrently. And what's going to happen, because we have these other services in AWS, we have basically something called a device shadow. Any IoT device, and our robots, we think of them as IoT devices, can actually keep a shadow of meaningful information in the cloud that's accessible. And so obviously for this robot, we're going to have its unique ID and its unique type, but as it putters around its gazebo world, we're actually sending data about its location, its orientation, and other information as quick MQTT messages. This IoT service will actually do a many-to-one convergence of all of these messages into a single repository. That gets sent up with timestamps in parallel up to a single consolidated. This room's not computing any robot movement, physics, or anything else. It's actually the same simulated, but I'm rendering the robots, and I can actually see what's happening in their interactions. And if they want to share information about location or proximity, we can actually send that information through the device shadow, and the robots can be aware of each other. So frankly, while we're running them partitioned and individually, they're actually aware of each other, and all that information can be actually synthesized into a single. I can't wait for Gazebo Ignition and the scale out, but this will apply to Gazebo 9 and Gazebo 7. Once we have this architectural pattern, it's just a feature to launch this. But this multi-robot simulation is actually a big blocker for a lot of businesses that actually want to use simulation for testing, but today can't scale up to that level, yet they need to know how 50 robots are actually going to work with each other in the same facility. And another big one that's come up, I can tell you about, is basically using simulation for model training. So again, the talk earlier about Gazebo, we love Gazebo, and we're actually can't wait to invest more into it. You can actually rapidly generate trial data. If you turn on high quality rendering, you can actually use the synthetic data that you create as images for machine learning algorithms. You can actually use reinforcement learning in the simulator, either with SageMaker, which is our machine learning as a service, or upload your own coach or whatever machine learning library into the simulation itself, and then run concurrent simulations, i.e. domain randomization, to actually allow these machine learning models to generalize. We've been doing this since launch, because when we launched, another service called Deep Racer launched. Deep Racer is a ROS robot. When it was first launched, it had nothing more than a camera on it, a deep learning camera on it. And we actually started competitions where these cars could actually race around the track in the real world. But they were trained from knowing nothing to actually being able to be deployed into the real world through simulation, running multiple parallel simulations of different racetracks until they generalized. All the developer had to write was a reward function. Is anyone familiar? Has anyone seen Deep Racer in this? Some people have. It's a big deal. I mean, on a weekly basis, we're running thousands of simulations to support this activity because they're having leagues and competitions. Companies are doing it for social offsites. And we just launched a new car that has a LiDAR as well as a multi-sense depth camera on it, so that we're going to get a lot more workload from that as they try to train these cars on even more complex sensor workloads. But the bottom line is, what's going on in simulation, the RL agent is trying to drive the car with some degree of success. It seems like it stopped. It's seeing simulation. These tracks, the colors, their shapes are intentional, so the model will generalize. After it makes a series of failures, those errors are aggregated, trained to a new RL agent. The RL agents push back down to all the cars, and this proceeds until finally the overall performance improves until it gets to a point where the car can be attempted to actually be published to the actual car. And this is where our fleet management I mentioned earlier, we can do an over-the-air update no matter where the car is at, deploy the physical model on the car, and it will then take over and start driving. These tracks are rather large, they'd easily fill up the front of the space, and they can get around it. Best record that happened at reInvent last week was about 6 seconds. Scary, but true, but there's actually people training real autonomous cars, not meant to be on the road, but instead to be working on fields and farms using this very same approach right here, using Gazebo, using RL, so I'll stay clear of them until I'm sure that they can actually drive. But we've seen other applications. I can't name the name of the customer, but they're able to buy hundreds of these drones and actually stick them out on oil wells and other sites where they want to actually do different tasks depending on what they care about. These things are reprogrammable targets. You don't have to program them once and ship them out because they're integrated with Robo Maker, which means what we offer right now is AWS Amplify is nothing more than a way to set up a website. The user can see all the drones they have, choose it by region. They can choose from a list of possible missions that have already been predefined. These are ROS programs. They can actually test in simulation to ensure that the ROS program is going to function for that particular site. Then they can do an over-the-air update and literally just change the mission of the robot at will. And if it happens to be they want to add a new machine learning model because they've been given many samples, photos of things that their model has missed out in the field, they can retrain their model using the resources of the cloud. We have a lot of compute, and then simply push the machine learning model onto a ROS node we have that archives the ML models. That ROS node is integrated with an NVIDIA chipset, which is actually running the model with the GPU chipset. There's a camera. If it actually detects what you're looking for, it actually records the video on the device. If there's a good network connection, it'll stream it back, but it can record what it saw. So it can say, I found this event, and it can set an alert, which again, if we have even a low bandwidth connection, I can get the alert. I'm sent back up to the operator saying, I found it, here's the location. If I can't get the video, I can at least get an alert that an intruder was detected, and hopefully it's got the image. It's changed how these people think about these drones. Once they saw that, they said, let's just put them everywhere on a recharging station, and we can reprogram them at any point in time. That's what I mean by this relationship between client and cloud. We can start treating our robots differently. I had one customer that has a concierge robot. It putters around a hotel room, answering questions, giving direction. His business model used to be he would program, give them a bill for what he programmed it for, he'd ship it to them, and it was a pretty onerous task to go back out and reprogram it. Now he sells his business as a service. Just like, let me know if you need new information. He actually now is thinking about actually operating an operator, which if the robot's detecting frustration in the customer, he can actually stream somebody's face and talk person to person, have voice interactions, person to person versus a robot. So again, it's a lot of we have to rethink about how we're going to think about robots, how they're programmed, how we interact with them, how we use them. Transitioning a little bit is actually deploying and updating these things at scale. We started off with the ability to just simply control deployment, register your robot. I would install a program on it called Greengrass that allows me to maintain a secure connection back to the AWS cloud, encrypted and all that stuff. It's a security model as well. You cannot get into the application running on that robot unless you have our public and private key that the user holds. And we can rotate those keys if we're not trusting things are constantly secure. So nobody can hack your robot. We build versions of this Greengrass for agencies, and there's actually no ports that can be scanned. They're completely locked down until you decide to open something on it. So it does give you a strong container. Let me go back, hold on. We pushed that a little bit further. We've now added the ability to view the robot health. We can stream records. You can choose a robot that you don't think is healthy and start immediately streaming the CloudWatch records off of it. We'll be adding the ability to teleoperate and connect onto any robot. And then you can also deploy across multiple robot bands. This is the big one right here that's coming up for us now. So we've talked to a lot of customers that said, yes, we've been buying and acquiring robots now for the past 3 or 4 years. Even from the same manufacturer, they have different capabilities, so I sometimes have a hard time keeping track of what can do exactly what. I've got 5 different makes and models. Each one comes with its own management interface, and I've got to learn 5 different pieces of software to actually operate all of them. So a big request that's been coming to us is actually give me a single pane of glass that can speak to all of these robots through a single command interface, integrate the information coming up from them, such as their health and other information, power level, into a single pane of glass so I can see its location. This is a big push for us right now. The ability to orchestrate across multiple brands, share map information, a single interface, and we've been doing implementations with customers with the following function. And we have actually got a customer in production right now, can't use their name, they're not public, where they're actually planning missions, robots coordinating with each other across multiple brands through this single fleet management one. A big push for theirs. What you can do today, you can register your robots with Robot Fleet. You can actually put them into these named logical groups: production fleet, fleet A, fleet B, fleet C, maybe by type of robot or where the robots are located. When it's time to actually push an update of your application, you can actually choose the specific fleet that you want to do the update to and commence an update. And only once that's successful, roll on to the next fleet and do that in a secure manner. We just added the ability to do conditional over-the-air updates, where you can write a series of logical functions, like robot has to be connected to power and or have 80% battery power, good internet connection, not actively doing things. You can write a series of conditions. All those conditions have to be satisfied before the robot can actually be updated. Big use case concern. Seems kind of simple, but again, unless you're getting that information off a robot, you don't know whether you can actually deploy an update to it. The monitoring and alerting, we've got this in progress right now, as well as the ability to actually do an automatic rollback if we have certain conditions satisfied. Again, you don't want a torrent fleet where half of them are updated to one version of your app and the other half to another. So we're adding features to help manage that. So my point for all this is, what is the role of the cloud in the future of robotics? Number one, we've seen strong evidence that the cloud services can enhance the local processing that you see on the robot. And you can actually improve it over time. As the machine learning models, you can always push new ones out. You can actually use simulation to test application correctness at scale, use that to gate your developers from pushing code into production and impacting the robot. Simulation with reinforcement learning can actually be used to program robots, and I think this is a hot area for us to be investing in right now. We've got ideas on that, talking to a few companies that are doing it at scale today. And all throughout these examples, I've been throwing in other cloud services, because every end-to-end application that we have worked with a customer to build a solution for their business where a robot was a piece of it, we actually had to use other services. Even in Amazon, when you place an order at Amazon, a number of robots are working on your behalf, but your order goes to a queue system. That queue system is being actually read by a polling system, which is actually thinking about where the inventory is in the database service. These end-to-end apps that customers need to build, a robot's an important piece of it, but these other services actually allow you to spin that up end-to-end very fast. So I think it's one of the unique roles, not only enhancing the robot, but trying to think about how you build end-to-end solutions. And I'm going to guess, how many people here have actually actively used cloud services? Yeah. And this is the thing that part of my, when I go to AWS conferences, I ask how many people have used robots. It's kind of the same. I got a Roomba, but so a lot of it's going to be education. I think this is a good thing. I mean, I do. I think we're going to have solution architects and others that actually are well versed in both what robots can do, what cloud services can do, and will help people bring this technology. This session about IT, I actually find myself spending a lot of time going to a company and talking to their IT group, and then over to the OT group about how they can use the robot to actually do something useful. And these two groups don't talk to each other. It's a really interesting transition we're going through right here. We were busy this year. Since I was here last year, we dropped the time to do an accelerated build bundle time for your Qualcomm packages by 80%. It was just a huge dissatisfaction to have to wait several minutes. We think we can get that down even further. We added ROS support for ROS Melodic. We added support for Gazebo 9. Robots do get disconnected at times, and so you actually need to have offline CloudWatch. If you're using CloudWatch to capture your logs and your ROS bags, your robot can go offline and will cache the data, and you can tell us the priority of what data, so that we have to throw it away. We'll keep just the important records until we get reconnected again. We support log-based simulation. People familiar with that, where you can take a sensor and a log of data for that, and when you run your simulation, it's not coming from the sim, but it's actually coming from a historical record of what that sensor saw. And so you can if you have historical data about when your robot failed, you can actually feed logs in for all of the sensors and actually see if it's now operating correctly with that. Or if you wanted to see if you could recognize faces, you could feed images in instead of having a camera. We launched in NRT, Japan, Frankfurt, Singapore, and a region over on the east coast of the US. We actually, because simulations can be expensive, but yet if you failed something you want to stop, you can actually trigger events. If you see something happening in the sim, you can terminate your simulation. And again, we just launched conditional over-the-air updates. I thought I could announce one other release, and I just want to do a check on the time. What time will we go to? We go to 2:50? What's that? Thank you. I'm sorry. I actually prepared more. I thought it was a 50-minute talk. I thought slides. So I'll talk a little faster. Sorry. I'll skip the one that didn't come. Let me tell you about your roadmap in case you're interested. Automatic rollback. I told you about that. We're adding a batch API. where you can actually call sim. You can actually pass all the tests to us that you want to do. You can pass all the different simulation worlds, and we'll run as a batch, and then give the developer an API call they can make to see which ones failed, which ones succeeded. We'll integrate that with all the CICD systems, so what we set up for iRobot will be dead simple to set up for other people. We've noticed a number of areas that we could add value to ROS-2, and so we're working on that with the hope of actually calling, for us, ROS-2 in GA. Right now, I'd say ROS-2 is a beta for us because we think there's features that should be there. For simulations, you may not need the GUI tools. You can turn it off. It'll save you money. GPU-enabled simulation. We're moving our fleet to GPU-enabled. And realistic rendering in Gazebo that just won't apply to Ignition, but Gazebo 7 and Gazebo 9. And just as a side-by-side, this is basically on the right-hand side. Your left-hand side, just standard Gazebo. On the right-hand side, we're actually sending the information. While Gazebo is running the simulation, we're sending the information to the Lumberyard rendering, which is an open source. We're porting it to Linux, much higher quality simulation. And with GPU, you can actually run much faster than real-time and much more complex simulations. We're about to close that decision. And the Cloud IDE wasn't such a winner. People want to develop on their own laptop. So we're adding support for containers. You can build your ROS application. We'll give you a container. You can actually bundle everything up in and send that up for simulation and then deployment to your robot. And we will support the use of containers and deployment of containers to your robots as well. So you have two options, Colcom build bundle. I'll keep this tight. We've made a number of contributions to ROS-2. This right here, we're taking an example from microservices. We're allowing you to actually build small containers that you would actually launch your nodes to, which gives you the ability to throttle them or set how much CPU or other resources they can do. In fact, all the way to draining up to 0 if they start to interfere with your robot. Different cross-compilation tools. We added quality of service. Are people familiar with the quality of service work that's been added to ROS-2? Some have? Okay, good. We add some security improvements and runtime analysis. This is the one I'm really keen on. Let me just move quickly. Message deadline. This will be in the slides, but you can actually set a deadline by which a message should be received, and failure or fallback action if that message is not received in time, which gives you a lot more quality of service control over message flow through a robot. So again, if you're about to hit a wall, the message is not received in time, you can actually take some corrective action and just stop the robot. Lifespan. If a ROS node fails and is recovering, messages that are still floating around could actually overload the system. You can actually set a lifetime and terminate messages premature when the timestamp's up. Heartbeats, you'll actually know if a ROS node is alive or just simply being quiet because there's nothing interesting to tell you about. So you have a much more understanding of what's running on your service. This is a good one, and I actually want something I want to encourage, just as I've been encouraged by others here about what we should be thinking about doing to ROS packages. We actually, whoops, I'm going to skip this one. We actually put ROS-2 core under modern code sanitizers, ASAN and TSAN. We found a number of issues in ROS-2D, many of which we fixed, others we shared with the broader community. We found lock order inversions, i.e. deadlocks, data races, unsafe signal handling, invalid memory leaks, and we put all of these checks into the ROS-2 build farm. So no regression will ever take place. Now I'd actually challenge anybody who's maintaining a meaningful open source software package to be thinking about putting these same tests into your build farm so that you'll be assured if you don't actually do the check and then somebody else does that there's never a regression. Because people are going to make commercial bets on this software and we can't have it regressing over time. This is a security threat model. I'm actually going to talk about something I care about before I close out here. Look, I do believe that we are going to see an explosion in the use of ROS and ROS-2 in commercial applications. I talk to thousands of companies that are AWS customers that want to automate. They're struggling to think about how to move forward on this. We need to have developers that are well-versed in ROS and know how to program robots. I know many of you are out there doing it and doing it well, but it needs to be much more scalable and happen at various points. We should intercept kids in high school. Or if you're familiar with FIRST, we're having a very active conversation with FIRST about starting to fold more ROS in, more simulation-based work into their curriculum that they're teaching kids. I love what they do, but I think there's an opportunity to actually set them up for better success. We partnered with AWS Educate. I've spent a considerable amount of resources on this one. AWS Educate gives free resources out to students and teachers to teach. Anybody with an educational account, at EDU can come over to the Educate site and get access to Robo Maker and get access to our service. We actually built a badge program that a learner could get. It was a fail. The person that said they could build a curriculum for us, I'm sorry, if she's watching, I'm dead. The person that said they could build a curriculum for us literally went through our manual and copied it down as exercises. And I don't want it about our service. I want it about learning ROS, learning simulation, learning the basic concepts of robot program so they can go off to college. I'll come back to that in a second. We set up the classroom where a professor could go and create a classroom, and we give them credits. The classroom allows them to create an account for each one of their students. They can monitor it. They can impersonate the student to shut something down, and then they can actually teach their class. University of Cambridge and 5 other universities have taught. Other classrooms have come around 6,000, actually it's closer to 7,000 students have gone through the program right now. Hasn't cost them a dime, but it's their teachers that are doing the hard work of actually teaching them. I'll come back to that in a second. And we're doing some fun stuff too. We announced the AWS JPL Open Source Rover Challenge, where developers can win $15K. The number 1 developer will win 15. But again, NASA has built this wonderful rover, open source rover, to model what they do on the Martian rover. It's running completely on ROS, integrated in Robo Maker, and we're doing fun stuff like this throughout the year, just trying to get the word out to people to write some code, write some ROS code. Next week, somebody's doing it in the Women Can Code workshop, and they're going to be programming ROS for the first time in a 1-week workshop. So, call to action. We have, do you have requirements for fleet management? We work customer backwards. We've got some early requirements. If you're running robots and have fleet management challenges, I'd love to hear from you so I can plug you in with our product managers who can talk with you to make sure that what we build and launch the first half of next year actually solves that problem and is useful. So please let me know. Do you have ROS tutorials or curriculum? We will host it under Creative Commons on AWS Educate and give students free access to the service. I don't expect a full class, but if there's little vignettes on how to use ROS, the ROS programming model, how to do simulation, I'd be happy to host that and make it available for young learners. If it looks meaningful, we'll even set a badge aside for it. You just won the ROS-2 badge for completing this course. I do have an RFP out for curriculum, a little bit higher bar, but again, I want people to be able to learn and use the service for free to learn robotics, or we won't have developers. And finally, look, it is still day one for robotics. A large number of enterprise companies are trying to figure this out. I, again, think AWS top customers are coming to me saying, how do I get started? I see some of our Amazon robotics developers saying, is ROS-2 for real? And what is ROS-Industrial? I think there needs to be a set of just simple white papers written by people in the community. What is ROS-Industrial? What is ROS-2 and why do we build it? I will talk to Brian Gerke about this one. I think examples of people successfully using robots. I'm working with Woodside right now to actually write one on what they've learned. Where do they struggle at? What do they learn from it? Some of you have gone down this same journey. I think this would actually be very useful for people to read and learn about. Otherwise, they're going to get misinformation or get pulled down other paths. And so if this community is about building even a bigger community, I think there's a chance to actually start educating and pulling people in to what's going on here. We've got a blog. Our team has started a blog article. We're doing interviews. I'll be talking to Dave Coleman about Move It and other things. So we'll be doing things ourselves as well. But I'm trying to crowdsource here. If anyone is interested in offering up something like that, I'd be more than happy to entertain the proposal and work with you with an editor to get it up there so it's not too onerous. And with that, I feel like I've actually used up my time. So I'll leave it at that. Thank you.